scared me.
Hello! I'm here today to talk to you about solving exponential log equations and scare people. Okay, we're solving exponential and log equations today. We're going to look at two scenarios for each, exponential equations and for logs. All right. Tomorrow I'll talk about second scenario. The first case of solving an exponential is where you have an exponential expression on the left side of the equal sign and an exponential on the right side of the equal sign. Ultimately, we're going to use an idea that you've already practiced for me when we were doing logarithms, where your goal is to make both bases on each side match so that we can just ignore the bases and focus just on the exponents. Let's take a look at what I'm talking about. If I have this equation right here and I want to solve this equation, 5 to the 3x plus 2 power equals 25. Well, if you take a look at this equation, the base on the left is a 5 and the base on the right is a 25. These two bases don't match, do they? But you say to yourself, oh wait, can I make this bigger, the bigger base of 25, can I rewrite him in terms of the smaller base of 5? Well, the answer to that is yeah, I can make him into a 5 squared, can't I? Isn't 25 the same thing as 5 squared? Well, if I rewrite the right side like that, wouldn't you get 5 to the 3x plus 2 power must equal 5 to the second power? Well, let it make sense, folks. In this equation, if the two bases match, if I both have a 5 on the left and a 5 on the right, I can pretty much ignore those parts and focus on the things that look different. Since the bases are identical, just cross those out because we're ignoring them and focus on just the exponents. Couldn't I rewrite the equation 3x plus 2 must equal 2? Well, if I solve for x in this exponent, I would get, well, let's see, that would be 3x minus 2 equals 0. Divided by 3, I get x equals 0. So the only way that this left side of this equation matches the right side is if x was 0. Let's plug 0 back into this equation and see if it makes sense. If I plug a 0 in for x, what's 3 times 0? 0. 0 plus 2 is 2. And what's 5 squared? 25. Oh, so it works, doesn't it? Let's take a look at a more complicated example. Suppose I have 16 to the 3x plus 2 equals 4 to the 5x plus 6. Again, my bases don't match, but I can take this bigger base of 16 and turn it into the smaller base of 4. Well, 4 to what power 16? 4 to the second power. But hey, didn't he already have an exponent of 3x plus 2? Sure did. So he's still there, and he will multiply by that 2 that we created. Well, that equals 4 to the 5x plus 6 on the right side. Now that my bases match, I can ignore them and just focus on my exponents in a new equation that says 2 parenthesis 3x plus 2 equals 5x plus 6. That's an algebra 1 problem. Would you agree?
Yeah.
Just distributing the 2, I get 6x plus 4 equals 5x plus 6. Subtracting the 5x across, I get x. Subtracting the 4 across, I get 2. So x should equal 2. And that's my answer there. So let's do it one more time. If I have 4 to the 2x minus 1 power equals 8 to the 2x plus 3 power, to solve this one, well, looking at this bigger base of 8, I can't directly change him into a 4. So what do you think I should change him into? A 2. That's right. 2 cubed is 8 times 2x plus 3. Well, that will equal, well, I'm going to have to break this base down. What should I break him down to? 2 squared times 2x minus 1. And now I've made the bases match, so I can focus on just my exponents. I get 4x minus 2. Did someone just say crikey? Crikey. Equals 6x plus 9. Solving for x, I get 2x equals negative 11. So x equals negative 11 over 2. And that's how I solve that one. And that's how we solve exponential equations, where I have an exponential expression on the left and an exponential on the right. My goal is to make the base of each exponential match so that I can cross them out and focus just on the exponents. Now let's look at solving log equations. Similar idea, where I'm going to have a log on the left and a log on the right. Ladies and gentlemen, take a look at this first example. I've got log base 3 of 2x plus 1 equals log base 3 of 5x minus 8. Well guys, since the log on the left matches the log on the right, since those bases match, does it make sense that the only way that the logs can be equal is if the arguments as well must be equal? Since the bases are equal, the arguments also have to be equal. So for all intents and purposes, I can just ignore the logs. I'm not canceling them, I'm just ignoring them. I'm focusing just on my arguments. So I get 2x plus 1 equals 5x minus 8. So solving for x, now we get 3x on the right equals 9 on the left. So I get x equals 3. Does that make sense?
Yeah.
Yeah, right? All right, now, there is one thing that we've talked about with logs. When we were graphing logs, didn't we say that logs have a restricted domain? What kind of number are you not allowed to have inside of an argument?
0.
0 or negative numbers, right? So I need to make sure that when I get this answer for x, if I plug him back into the original log, I better not get a negative number for the log's argument. I better not get 0 for the log's argument. Well, if I plug in a 3, for this x in either of these original arguments, I need to avoid 0 or a negative number. Well, if I plug a 3 in here, 2 times 3 plus 1, well, that's definitely going to be positive, so he's okay. If I plug a 3 in for this x, well, that's 15 minus 8, that's 7, that's positive. And again, I don't really have to, all I care about is I'm avoiding zeros and negatives. If I plug a 3 in for either of those x's, I don't get a 0 or negative, so that's okay. My answer is 3. Take a look at the next equation. Folks, this is one we really want to focus on. I taught you an idea of condensing logs in a previous lesson. Well, here's where we're going to use it. Ladies and gentlemen, I've got 2 logs on the left side of the equal sign, and I've only got 1 log on the right. Folks, what you do to one side, you have to do to the other. Correct? If I wanted to drop the logs from the left side, how many logs would I be dropping? 2. How many would you be dropping from the right?
1.
That doesn't make sense. If I drop 2 logs from the left, I'd have to drop 2 logs from the right. But the right side doesn't have 2 logs. It only has 1 log. So you can't drop them right now. But take a look at this. Isn't it true that I can condense logs when they're added? 2 logs added becomes 1 log multiplied. So couldn't I condense this left side into just the common log of x times x minus 1, which becomes the common log of x squared minus x. Well, that equals the common log of 6. Well, now, since I have a single log on the left and a single log on the right, now can't I drop the logs and solve the arguments? Sure I can. So when I do that, I get x squared minus x equals 6. What kind of equation is this called? What kind of equation is this called?
Quadratic.
It's called a quadratic equation. I know that when I solve quadratics, I always have to start with one side being 0, so I subtract the 6 across, and then I go from there. Can I factor x squared minus x minus 6? Yeah, into,
3 and 2.
good, so minus 3 plus 2. So I get x equals 3 and x equals negative 2. Now, if I take this answer of 3 and I plug it back into all the x's in my arguments, I need to make sure I avoid zeros and negatives. Well, 3 in here produces an argument of 2. That's okay. 3 here produces an argument of 3. That's okay. So 3 works. Let's try negative 2. If I plug a negative 2 into this first x, is that okay? No, that produces that negative argument, which is undefined, isn't it? Right? So negative 2 doesn't work, so we cross him out. Now, as a side note, what do we call a value that, I know my math is impeccable. I know that's the answer is correct. What do you call an answer that you know you've done correctly, but he still doesn't satisfy the original condition, the original equation? or we call it extraneous, right? Extraneous.
Extra calm.
All right. Hey, who wants to hear my imitation of Mr. Melendez?
Me.
Yeah. Okay.
Something.
My shoes cost more than your life.
I laughed at pity.
What's your problem?
What's my problem? I have no problem. What's your problem? What do you think of this? You like this shirt?
There's a stain bigger than your face.
Bigger than my what?
Than your face.
Really?
Bigger than your belly.
That's hard. It's all over my belly.
Child.